Okay, so today on an episode from the Ed of Ed, I have a 3D printed project here to extract key buttons from mechanical calculators and adding machines. The idea being that rather than using a screwdriver to extract these buttons, which are probably made out of very early plastics that are possibly quite brittle, and obviously the keys are pretty much irreplaceable, I decided to come up with a keyboard button extractor that will basically pry the key out in a nice linear manner. The key will sit, you'll basically come up to the side of the key and get it to sit in this pocket, and the key stem sticks out to this slot here, and then the key will be pried out hopefully in a nice linear manner. And I'll have these files on Thingiverse. The plan here is to use some brass tubing to act as a kind of a bearing bushing, and then some 632 screws to tie all those guys together, and then some 440 screws to tie the two symmetrical linear racks together. And metric screws, I'm not sure what those would be, but I'm sure there's equivalent that's got to be pretty close. And if you don't have brass tubing, you could use a 1032 screw will work in this. It obviously will wear out the plastic much quicker with just the threads up against the plastic, but it'll probably easily last the removing of all the keycaps on at least one machine, maybe several. And the brass tubing is 3/16 1875 tubing that I've cut to just a smidgen over a ½ inch. The screws are, like I was saying, 632s, and they're 3/4 inch long, and of course some nuts. The rack and pinion, I've sized the holes for a tapped hole size, and I like tap stuff, but you could of course just use a nut. But the best thing to do is of course chase the holes out for the threaded side and then thread them, and then you'll need to drill them out for the through hole or the clearance side body size of the screws, because they're just simply the same file for both, and it was just easier to do that, and you just drill them out to the finished size. Usually for most 3D printed parts you really do need to drill to a finished size, because the 3D printers just don't print quite accurately enough to really get a true finished size. So first of all, we'll see what we can do about putting this guy together with his little key extractor thing here. And the truth of the matter is you probably don't even need the other side. I'm guessing that the one side would do, but I do have it threaded and tapped on the other side in case I decide to do so. This guy here has a square hole down the center that this guy will slide in. It's kind of nice about 3D printing, you can actually produce square holes very easily. The brass tubing pushes in here. The question mark is getting the rack and pinion at a position where you would want to, I would think you'd probably want it to where when you pull up, you push down to pull up on this guy. So what you probably want to do is get the position where it's easy to start and then push down on these guys. So I would think right about there, where the key is about ready to come through, and I'm going to size this guy, try to position it so that it's kind of level here if I can, and get these arms to be somewhat symmetrical to each other. Now the biggest challenge is getting the tubing through these bores, which I have not reamed out. I probably should have, but I didn't do that. They seem to fit otherwise pretty well. Let's see if I can get this thing to sit at the same height. Sit there nice and symmetrical. The symmetry isn't getting kind of weird on you. I think they're actually pretty close. If I might need to come up a bit. See, is that? I think that's pretty close to level. They look level. Okay, so you got your key on there, and you press all the way down. I think that'll actually work pretty well, right about there. Now I can get this guy, that last little bit in there. Always that problem is getting that all the parts to fit, and the compression of the gears on the rack and pinion might be a little tight, so it's convincing this guy to get through is the problem. I could have probably chamfered the tubing a little bit, and that might have helped a little bit. If I had troubles with that, I might do that. Assuming I don't lose my nice levelness. There we go. Are we level still? It looks like I think we're pretty good. So I think with that we can go work. Yep, well, I think we're pretty good. Okay. So it's, like I say, some 632s and some nuts here. And then those 632 screws will just compress on that tubing and won't force these plates together and compress against the gears. So the reason for the brass tubing, and also just the threads don't chew it up. But, you know, a 1032 screw would work fine. So there we go. It's pretty straightforward. Let's go see what happens on an actual calculator. Okay, so here's the 1921 Model K Monroe mechanical calculator. And I was planning on removing all these keycaps on this guy in order to put this whole thing in a solvent tank. And of course the concern is that these keys are made out of some kind of an early plastic. I'm guessing it's probably Bakelite, but it could be a cellulose with some sort of a varnish over it, or it could be celluloid, I believe. So it was celluloid, some sort of like a composite, like a I think they did something like a paper mache with a lot of varnish over it. But chances are this is late enough era early plastics that this is probably Bakelite. And they're probably fairly tough, but they might break. And I was just planning on taking all these keys off in order to dunk this whole thing in the solvent tank, but I just happened to see the latest episode from, I believe, the fellow on the BSD 250 channel, and he happens to be working on a Monroe calculator at that point, and he showed that you actually can take the keyboard out, and so it's a good thing to actually see some other YouTube videos. So I guess these actually come out with these screws, so I may not actually have to take these keys off, but I might in the future. And I've acquired just recently some adding machines that I'll feature in some future episodes, so there may be an opportunity there to use it for that. But I thought at the very minimum, we'll see if this guy will actually work. So what I have here is my 3D printed keyboard extractor, and I'll have, like I say, that file on Thingiverse, and we'll see if this little guy will actually work. So this guy will fit into these keycaps. And the awkward thing, of course, is there's just not a lot of room in here, so we'll see. Well, I guess the one thing I'm already seeing right now is these keys are going to be in the way of each other. So this idea might not work, I don't know. Let's see here, let's try it over here. The keys are really close to each other, so maybe this design won't work. Oh, it pulled that sucker right off, okay. And that came off really easy. So maybe what I need to do is I'll just work systematically down a row. It seems like the red keys, which are the 0 keys, interesting that the 0 keys in this machine. Later machines are always, have a 0 on there, but here they don't even put a number on there. It's just red, which isn't really 0. It just pops these keys up and keeps anyone else from actually being entered. So we'll see if I can get number 8 out of here. Let's see here, right there. And we'll see if we extract that out. Oh, hey, this little guy works pretty good. So, I might come up with a revision that is a little bit tighter, but you can see these keys just barely get enough light in here. It's always the problem with these video stuff, is getting enough light in here. Hopefully you can see that. The key sits in there very nicely. I could try and shrink it down a little bit more. These keys stems are quite wide, and you can only come at it from one direction, which unfortunately, I guess I could tilt the camera this way. I think I can come at it from this angle. I think I'm probably, actually, there we go. I think I can do that there. Okay, I can come down. I'm in. So I'm learning this as I go. It's all a learning a real-time process here. So we'll extract a key here together. All right. Hey, that actually works really well. I'm really delighted by this. Ironically, I probably don't actually need to take these keys off because I can take the whole keyboard off. I was under the impression these really early adding machines, calculators, I think this is a calculator, not an adding machine, by the way. I guess there is a big difference between the two. Calculator, you have this moving carriage typically in an adding machine. They don't have any moving carriage. They usually only can do adding, and they usually print on paper. So I guess that's the big difference between the two. Okay, so with the extractor bucket, I'll call it that, or finger, all the way out, I can kind of get in there, rotate it around, get it into that stem, and give it a pull, and off it comes. Hey, hey. So it's nice to see something work really well. So there we go. There is my FreeCAD designed, 3D printed. The files will be on Thingiverse keycap remover, and it works actually pretty well. And you know, it's kind of inspired on a wine bottle remover. I bought this thing thinking I could modify this guy, and it just didn't work. And just easier to come with a rack and pinion system and original design. Obviously, this is too big for that, but obviously that's where the inspiration came from, and it works very nicely. So I hope you enjoyed that. It was fun to do.